Hang on for a second. Yeah. So this is our agenda today. So it's going to be a demo on VMware vSphere ICM. ICM stands for Install, Configure, and Manage. So this is the baseline program, you can say, for all the VMware technologies or all the VMware products. Before going for any other VMware sort of technologies, you have to understand about VMware vSphere ICM. It's basically related to system administration. That means you can administrate a VMware vSphere environment after going through this program there. So we'll understand virtualization basics. We'll understand VMware products available for virtualization. We'll install one of the product called ESXi. It hardly takes 5 to 6 minutes. Then we'll create virtual machines. Then we'll do some cloning sort of thing, and we'll understand snapshots. So this is going to be our agenda today. So I would like to know, have you ever installed a virtual machine?
No, I have never installed. Yes.
Okay, so can I know a bit about your so yesterday we had a talk, right? So
Yeah.
you told me that you have 9 years of experience in support there, right? So now you want to move to system administration.
Yes, and also I have not been working on Linux. So I'm in telecommunication. So if you are aware, I was working on radio access network.
Okay, excellent.
So, but nothing related to Linux or a system administrator profile. So I was working in various different domains like testing, planning, and support, but for Ericsson equipment for radio access network. But now there are some because in telecom this cloud thing is going forward, and we have a couple of projects coming up for VMware Vsphere. So I just thought that maybe it will be good to have some competence there, and then I would like to take up some projects which are related to VMware. So I would like to be a part of these projects. So whatever knowledge I have so far from VMware, I have acquired it by learning myself on internet by some videos from where I came across your video basically on YouTube, and that's why how I contacted you, and so things like that. So I have also access to a test system here via a colleague who works in the VMware domain. So he just unofficially I could get connected to some vSphere environment where I tried to boot up a sample VM on vSphere. So I'm aware about some concepts, but nothing in detail. And I have never installed this ESXi on hardware because I have got a setup lab where there is a vSphere, where there is a vCloud director, and they are already connected to it. But I used it to create some virtual machine and some basic distributed groups which I created and things like that.
Do you have a desktop at your home or a laptop?
Yes, I have a laptop.
What is the configuration of your laptop?
Check 1 second. It's 8 GB RAM,
Yes.
and hard disk I have bigger one because I have got an external hard disk also connected to it. So hard disk I have a pretty good space. So I have around more than 200 GB available space with me.
Okay. And what is the processor?
Processor is Intel i5 4310.
Exactly. So I hope that you will be able to do almost all the labs over there in your laptop itself, right? Except a few.
Okay. Okay.
I'll guide you how to create a lab environment at your home. So if you upgrade it to your 16 GB, you will be able to do all the labs. In fact, preferably say 88 GB is in fact not enough for this virtualized environment. This is what I mean to say. If you upgrade it to 16 GB, it will be more than enough to do all the labs. Otherwise, you have all as you said that you have got access to a data center there where you can do the labs. So the basic thing is that you brush up over there in your friend's data center environment, and you take up the labs over there in your laptop. This is how you will be able to manage the things, and I'll be
But
guiding you how to
sorry,
do that.
sorry, sorry to interrupt you, but there I don't have any access to a bare metal host where I can install the CSXI by myself.
You don't require to install an ESXi, right? So point
Okay.
is that you need to understand how to install an ESXi and how to create a virtual machine. Once you understand
Mm-hmm.
how to
Mm-hmm.
install an ESXi and how to
Mm-hmm.
create a virtual machine, then I just make you jump to some of the data center. You will be able to identify that environment, that okay, fine, this is an ESXi and this is a virtual machine. This is VMware
Mm-hmm.
vSphere. This is how we fire the command, right? The point is that
Okay.
you will need to first of all visualize that this is the way we fire in the command, that you will be able to do in your laptop itself,
Okay. Okay.
right? I just want to make sure ensure you that you will be able to lab up the things in your laptop, right? Don't worry
Okay.
about it.
And
Okay.
just to ask you about a little bit more on the course content, will you be covering anything related to vCloud Director also?
No, no.
And do you provide any course related to it? Like,
We obviously do provide a program related to vCloud Director and vSphere, VMware vSphere or VMware Horizon particularly. That means we provide these level of courses. But again, for any of these
okay.
things, you will have to go through this program, VMware vSphere ICM, because this is the
Okay.
baseline. This is the first
Okay.
step towards virtualization in VMware's product.
Okay. Okay. Actually, I'm asking this because, as we discussed yesterday, you will be kind of customizing the course based on somewhat my experience and my needs. So I was just wondering if, because I'm interested in learning vCloud Director as well. So if we can make a consolidated course which can have both the components, it will be even better.
First of all, I'll suggest you to go for a VMware vSphere ICM, complete the
Okay.
labs, finish off the
Okay.
things, because there are a whole lot of things to learn here itself, right?
Okay.
And then you move towards vCloud Director.
Okay.
Take up 1 or 2 months of experience and put the things or plug the things into your head there, and then you go for
Mm-hmm.
VMware vCloud Director. Otherwise, what will happen is
Okay.
that you'll understand how to click the mouse, where to click the mouse and do what, right? But you'll not understand what is exactly happening in the background. Why did
Okay.
it work? Right. So
Okay.
I will suggest you to
Okay.
go for a 1 or 2 or 3 months of brushing up this course over there. Don't just
Okay.
learn this course and jump towards vCloud Director. This is not right. Even if you go
Okay.
to your what do you say, VMware's official website and look at the
Mm-hmm.
requirements over there, they themselves have recommended that you should have a minimum 6 months
Mm-hmm.
of experience before going for an official program. That means
Okay.
once you go and ask for a VMware official program, this is not an official program you're going through, right?
Mm-hmm.
So
Mm-hmm.
if you go for an official program, even you should have a 6 months of experience there,
Okay.
right? So better you
Okay.
learn this product, brush up your things, look at 1 or 2 data centers over there. There are a whole lot of
Mm-hmm.
cloud infrastructure where you can just pay something and practice the things or lab up the things on your own, right? So I'll guide
Mm-hmm.
you towards the steps to make the things and make the things good and ensure that you learn the things well,
Okay. Okay. Okay.
right? Okay, so let's begin. First of all,
Yeah.
let me make you understand why did we jump to virtualization. And uh, before moving to why did we jump to virtualization, point is that virtualization is not new. It's a very old technology. Exactly, virtualization existed or virtualization began right in 1970s when people started using mainframes and they started using something called website hosting. Okay, try to understand one thing. We have one bare metal, right? And inside that bare metal we have Linux, and inside that Linux box itself we can host multiple websites, right? I hope that you know about website hosting, that
Yeah.
this
Yeah.
happens. How does this happen doesn't matter to us. But exactly, we know that this happens, that inside one bare metal, we have one Linux box and we have separate websites over there. Once that means people making a request on port number 80 will be redirected to different websites depending upon the URL they have typed in. This type of hosting is called named based hosting. And this type of hosting in Linux world is technically called virtual host, right? So this is where virtualization came into picture. Now, Microsoft took a different strategy. What they took about where they exactly implemented virtualization. You might have seen remote desktops, right? You do MSTSC. You obviously, I'm sure you might have done MSTSC in one or two point of your life, right? You can grab desktop of another system right in any part of this world. You just type in run MSTSC and let it come back, and this is the IP address over there. This is the port number to of the system that I want to connect, right? If I just press over there, enter, I'm able to connect to that. If I just type in username password over there, I'm able to connect to that, right? So this is the desktop of one of the systems that I have got. Okay, so think of a situation that this machine is located somewhere else. I am getting the desktop of that system in some other part of the world. Now Vinayak got that system's desktop. Now let us say Srinivas is sitting somewhere in Hyderabad. He just types in the same thing, run MSTSC and this IP address. He'll be again able to grab that same desktop from in Hyderabad. That means at the same point of time, I am having the desktop. At the same point of time, Srinivas is having the desktop. At the same point of time, you are having the desktop. The bare metal remains the same. So don't you think that this is a virtual world? This is the thing that I'm seeing. This is virtual. This is a virtual desktop that I'm seeing. This does not exist physically in front of me, but this exists virtually in front of me, right? So this is where exactly virtualization began. That means think it logically. What is actually happening at the lower level? We have only one kernel, but this is the shell. This is the shell. Okay, operating system is divided into two parts, shell and kernel. So shell is different at three different places. One is with me, one is with Srinivas, one is with you. So three different shells, but kernel remains the same. At the lower layer, we have only one box, one hardware with one kernel with three different shells. So this is exactly virtualization. That means what we have done, we have logically divided the bare metal, or we have taken a saw, which is particularly a software, and we have just cut that hardware into several pieces, and each piece exactly represents a machine, which is particularly called virtual machine in terms of virtualization. Now the question is, why did we do that? Part is, see, this is my laptop over here. Let's open the task manager and let's come to performance. So you can very well see that I am hardly using 28% of my memory, system's memory, and 33% of CPU. So it's almost 30% utilization of my system. So if I power up a virtual machine, so this is how we power up a virtual machine in VMware Workstation. So you have used virtualization, so you might be aware of this. This is not a new picture for you. So let me power on any of the machine over here. So if I just, it's having a 2 GB of RAM, one processor. This is a virtual machine with 2 GB of RAM, one processor. So if I power on this machine and then go back and look at the utilization of the system over there. So it's now 60% utilization, and you can see that the graph is just moving upwards over there. So this will just move on to plus 2 GB or whatever utilization it was earlier. Now the point is, take this in the terms of your chief financial officer in an organization. Your chief financial officer has a budget of 1 lakh rupees, say, to be invested in a hardware. Now you since you are using that for only one machine or one purpose, like this, my laptop, only one purpose, so he does not have any sort of virtualization. So he is going to utilize 30% of that. That means he is going to get an ROI, or return on investment, of 30%. So this is something commerce I am talking about. So now the point is, if he just moves on to virtualization and he pumps up a few virtual machines on the same machine, he can run several machines over there. So this is one of the Linux machine. I'm just powering on one of the Windows machine over there. This is having 4 GB of RAM and some 2 processor. So you can see very well see that the CPU utilization is again increasing, and it'll just increase in a couple of minutes. The memory has just been grabbed from the hardware. The point is to maximize our return on investment and to lower total cost on computing. we have moved ourselves towards virtualization because our hardware was not completely utilized. So we found a new methodology wherein we can just break that hardware into several small pieces called virtual machines, and each virtual machine will act like a physical machine, though it will not exist physically. Got the point? Anything to ask over here?
No, it's clear.
It's clear. Okay, so you can see that the middle graph is just moving upwards. So now once we move on towards our real program, I'm just not going to show you in the demo. I can just pump up more number of machines than the amount of memory I have. Let me show you one example over here. So let's say I am having 12 GB of RAM. Let me show you over here. So I am having around 12 GB of RAM, right? So I want to power up a machine. Okay, let's take this machine RH7C, and it's having 2 GB of RAM. So I'll just want to have it powered up more than, okay, so I'll take it as 11 GB or something. So it's 11.3 GB. It's already powered on, so it's 4 GB plus 2 GB. So I'm using 6 GB over here. So I want to additionally pump up a machine that is of 12 GB. So that means I am having 12 GB of RAM, and I want to pump up several machines. 12 plus 6, that is 18 GB of RAM, 18 GB of machine, or several machines which cumulatively come up to 12 GB of or 18 GB of RAM. So will I be able to do it? So let's power it up. So you can very well see that the machine has come up, right? So it didn't complain me. So this is having 12 GB. This is having almost 4 GB.
Can you please just explain this scenario again? The total.
Yes, sure. I'll explain it a bit. The point is that my hardware had 12 GB of RAM, right? Now this is my laptop. This is my base machine. You can say my base machine would be utilizing something. Let's consider 1 GB, right? So I am remaining with 11 GB of RAM around to work, right? So now I pumped up a few virtual machines which can accommodate this 11 GB. So this is my machine with 2 GB. So this is being powered on. So now I had 11 GB, so minus 2 GB, 9 GB remaining, right? So I pumped up this machine again. So this was 4 GB. So 9 minus 4 GB. So that is again 5 GB remaining, right? So now again I powered on this machine which is of 12 GB, right? But still I was able to power it on because now the mathematics told us that I had 5 GB of RAM remaining, but I could power on a machine that is of 12 GB. So this is beauty of virtualization, right? That you can overcommit. This is called overcommitment, right? So this is overcommitment of memory or overcommitment of RAM. Now overcommitment of hard disk can be done. Overcommitment of processor cannot be done, right? So the point is that since overcommitments can be done in virtualization, that is why we again moved towards virtualization. That means I don't have this much amount of memory, but still I can use machines of that much of memory, right? Why it is possible? Now there is there are certain technologies called swapping. There are certain technologies called time sharing. There are certain technologies called memory mapping. These sort of technologies work internally to make these things function so good or so well in a timely fashion. We'll discuss about the whole of the internal picture. How did it exactly function in one of my classes out there. Okay, so basically the second point was overcommitment. Now the third point over here is that these machines don't exist physically. These machines exist in the form of virtual world. Now since this does not exist physically, that means they exist somewhere inside the computer. Now somewhere inside the computer means what? Somewhere inside the computer means there is no God inside a computer. Everything inside a computer is a file, right? So these machines are files inside a computer, right? So now where are these files located? So let's just bring up the mouse over here. So this cos A is located under c:/vms, c:/vms /cos A /cos A.vmx. right? So this is the name of the file. So let's move on. So let's come over here, C drive, VMs. This is the name of the machine. This is the machine, right? So this is the machine. So these are the files that make up this machine. So if I look at the things, look at what will happen to this one. So if I just power off this machine over here, see, one or two of the files will be deleted. So you can see there, right? So this log file was deleted. This is the hard disk of the file. This is the memory. This is the NVRAM of the file. We'll discuss about what is exactly significance of the file. What should we do with this file, and our treatments we'll discuss later. Basic idea is that this machine exists in form of files. Now this is a very big deal over here. Since this machine exists in the form of a file, so all the treatments that we do with a file can be done over here. That means if I just right click over here, copy and paste it in my pen drive and give it to my friend, he'll be able to run that same machine in his laptop, that with the same configuration. Okay, so this is what we like in today's world, right? Your organization got a contract that, okay, I need this configuration, I need this sort of machine with this sort of apps, this sort of memory management, this sort of registry settings, and this and that. So what you did, you created that machine right on your laptop at your home with a cup of coffee. You took that machine, backed it up in a pen drive, or just planted it to Google Drive, give him the URL, told him to download that, and he can very well finally run that machine with the same configuration. He doesn't have to bother about any settings and all, right?
Just to ask here, like if I simply copy this COS save folder and give it to a colleague of mine, and he places it on the same path on his laptop where he has a
Not
VMware
even
workstation.
path is required. Not even path is required. If he just plugs that pen drive and goes over here, file, open, and he finds out that virtual machine and plays it over there, it will play simply like the machine that it was playing on your laptop.
And it can be placed in the form of the same folder.
It can be placed in the same folder.
Okay.
So this is the beauty, right? Things like your Aishwarya Rai's movie, right? So you have a Aishwarya Rai's movie in your hard disk, right? You gave it to your friend in a pen drive. So does he need to copy it in his My Documents, or does he need to copy in his movies folder? No, he just can directly run it in a pen from the pen drive. So this is like a Aishwarya Rai's movie with a play button. You can see over there, right? So these VMware guys, they have designed the product so nicely that they have given a play button because it plays like a movie. It streams on your desktop. Okay, now next point. So since it is a file, it can be backed up, it can be versionized. That means this is my version 1 virtual machine, this is my version 2 virtual machine. Next point, there is something called cloning. So if you go to here, manage, you will find something called clone, right? That means you can directly clone this virtual machine. This is not the right way, this is not the right method to copy and paste the machine in a pen drive, though it works properly. It's not that it won't work. It works 110% the same way. But the right method to do it is to manage and clone. Now, why I'm exactly telling you about the clone? Okay, what is this? This machine? It's having 2 GB of RAM, processor 1 GB, and hard disk is 20 GB. So what is expected is that this folder should be of 20 GB. Now the point is that a machine is a machine because of a hard disk. Try to understand this point. A Windows machine is called a Windows machine because it has hard disk with a Windows installed in it, right? A Linux machine is a Linux machine because it has a hard disk with Linux installed in it. So this folder exactly has CentOS installed with a 20 GB disk. So what is expected is that if I go to properties, I should be saying 20 GB. What is this? This is not 20 GB. This is 3.64 GB only. What? Why it is so? This method is called thin provisioning. That means I gave you a 20 GB disk, but this 20 GB disk is exactly used up to an extent of 3.4 GB or 3.64 GB. That means I still have 17 GB to be extended. Try to just close your eyes and feel this one. That I gave you a physical machine with a 20 GB disk, right? You used it to 3.64 GB. That means you still have 17 GB remaining. That means you can extend it up to 17 GB. Now here the folder size will be exactly the size of the space utilized in that virtual disk. It will not be exactly the total committed hard disk or committed virtual space. Now we can commit the whole space over there. That's a talk of for another time. That means it could show 20 GB at first front, but by default it's thin provision. Now the next beautiful thing that you will love is if I clone a machine. So if I manage and clone this machine, cloning means what? Copying. So cloning, a clone should be of exactly the same size, 3.64 GB. So let's see the current state of a virtual machine, create a linked clone. So I am going to clone it in C:/VMs clone of COS-A. So here there will be a folder created. So click on finish, click on close. So this machine is created, clone of COS-A. If you just right click over here, go to properties. Oh, what is the size? 2.57 MB. Yes, this machine is exactly the same machine as this one, and it will work the same way, and it is of 2 point something MB. So what will happen if I power it on? So let's do that. So if I go to this one machine and if I power it on, okay, now let's find out the size. Go to properties, still the same. So let's wait for a second. Okay, so 2.74, it's a bit increasing. Properties 2.74 is still the same. So let's wait for some, and let's power on this machine completely, and let's see what happens. Can you see some? Can you hear some background noise?
Yeah.
Please forgive me for that. Exactly, people, some neighbors are there talking.
Okay. One question in the meanwhile.
Yes, please.
What is the difference of you created a clone of this machine,
Yes.
and if I just copy and paste this machine and in the same folder?
The size. The difference is exactly the size. So this machine is not coming up. It will come up in a second. I know that. It takes time. It's just reviving itself. Right, it's exactly the size. That means if you just copy it and paste it over here, it works the same way. So I'm pasting it for you. Hang on for a second. Paste, and I'll show you the lab. So it's going to be the same size, right? But if I clone it, it's not going to be the same size. It's exactly the size decided by VMware that what should be the size of the clone, and it's going to work the same way. So I'm just rebooting it once. CentOS takes a time. It takes a bit of time. So I'll
is there any limit up to which we can overcome it?
Obviously you cannot just tell that I can have. Let's see if I move this to 64 GB, what happens? This will happen.
Okay.
Got that? It will tell you that see, boss, you are talking too much, right? You should not talk too much.
But is there a calculation on the basis of which we can decide how much?
This is a bit of trial and error method, right? Why this is there is a calculation. There is a calculation for resource allocation. 4:2:1 is a ratio we will divide. There is a calculation, but exactly the calculation does not work properly. It's only 50% of times the calculation is going to work. It's most of the times what we do, we exactly power on the machine. We take the baseline that how much of memory the machine is utilizing for a certain period of time or certain days over there, and then we exactly gradually decrease or increase the amount of memory depending upon that baseline that we have obtained.
Okay. But
Right.
there is no guidelines like some dimensioning sort, like if we have some resources with us and if we
There is.
are
I told you, there is a ratio 4:2:1. That means high. If you want to commit high amount of memory, okay. Let me explain. You have got 10 GB of RAM. So if you want to give high amount of memory, so you have to go for 4:2:1 ratio. That means you have to come just calculate it and give the fourth part to that machine over there, right? But again, the point is that exactly is not 100% going to work every time. The calculation is that means out of 10 GB you can give 4 GB to that machine. You have given more amount of memory, right? But it is not sure and certain that it's going to work. So you have to tweak that machine a bit couple of times when that machine is not working. That means calculation is there, but that calculation might not work depending upon the situations.
okay. Will we be covering something like a resource allocation in this course?
Yes. You, if you would have seen that a table of content that Srinivas has shared you, there is a separate chapter for that. So you can see that the clone of C cos A has come up over there, right? So this machine has powered on. It's just coming up with the screen over there. Hang on. Okay, so the screen has come up, and let's analyze the power size of the. So it's still 12 MB. Can you imagine that I am running a full Linux box in 12 MB? Right now, this is where these people from Azure and Google Cloud Platform and Amazon Web Services and this and that have started providing cloud services. How can these people provide n number of machines to n number of people? Nothing big science behind that. When you exactly ask these Google Cloud Platform or Azure or Amazon Web Services that spin me a machine, so what they do exactly, they have already an image set up like this for you, right? They have a base image, they clone them and throw it to you. That is it. And that is why the amount of memory consumed or amount of space consumed is too less. So they are hardly bothered about the space being consumed. And you, since you are getting the full interface, so you are very happy that, okay, fine, I have got the full interface. It feels like that I have got a 20 GB of space. The point is that in Matrix, you might have heard about Morpheus telling what you feel and what you see and what you feel is real. This is the essence of virtualization, right? That was a full movie on virtualization, in fact. So that in that Morpheus, guru of this virtual world, told us that what you see and what you feel is real. So if you are seeing a CentOS machine over here, that means this is a CentOS. You are hardly bothered what is happening in the background, but in the background that is running under 12 MB only, 14 MB. So it will go on increasing a bit. And to what extent it will increase? 20 GB. Maximum limit is 20 GB. Okay, so the next
and the
point
only difference between installing this machine on a real hardware and on a virtual is this thin provisioning, that it will keep on extending the size but it will not reserve. But in the meanwhile, if I am installing the same software on a hard virtual hardware, or sorry, a physical hardware, so it will be still occupying this 12 MB space only, and the rest will be just idly.
Exactly. So we were experimenting with one thing. So I'll skip this one. This was a log file. So okay. So this machine is over here in my pen drive, right? So this is cos A. So you can see this is E drive. I have that machine itself. So I'll just pump up this machine again. So this is again, this is the machine over there in C drive, C:/VMs. You can see over here. This is the machine over there in E drive. So both the machines are same with the same configuration, with the same amount of space being consumed. So I copied it. Yeah, I really copied it. Okay. So you can see over here that the amount of files that is coming up is increasing, and you can see the size over here is exactly the same size or as the original machine. So that is why we could have right click copy and right click paste over there, but VMware exactly gave us a solution that no, you should not do that way. You should exactly do it this way: manage, clone, thereby you will be saving the space. And henceforth we are exactly using this VMware product, nothing else.
But
Otherwise
by doing this
copy-paste method.
clone, there will be some files missing, which will not be there in this clone.
Very good.
Uh,
Excellent question. Excellent question. Excellent question. Exactly why did it exactly do it? Or what happened in the background? See here, they exactly created a snapshot. See here, this is cos A. This is the original hard disk and this is the delta hard disk, right? That means this is exactly having the changes that we have done to the clone. I mean to say that, think it this way, that I want to clone you. So what you have, your image or you physically is a base image, right? So what I did, I right clicked on you and I cloned you, sir. So what you did, you created a image of yours, you created a copy of yours, but that copy is having lesser size. Why? Because exactly that copy is having nothing. You are having everything inside you. So why should the clone have everything? The clone will only have changes. So I am making that clone having a mustache. You don't have a mustache, no problem. The clone has a mustache. So clone's mustache is something extra attached to the clone over there, but exactly the brain remains the same. That means the base image is exactly the same, right? The base image is this one, and this is the extra changes that we are making. That means whatever changes we will make to the clone will exactly be reflected over here. Got the
and
point?
then it will, sorry, but this cos A, the base image which you are talking about, this
Yes.
did not exist before we created a snapshot.
No, this base image exactly created every time, right? Okay, let me do it once again for you so you will understand it better. So I am just doing one thing. I'm powering off this machine. I am powering off this machine. Okay, so, and I'm closing everything for you. So this is a machine, that is in my pen drive, right? That does not have a clone. So this is the machine. This is the machine that does not have a clone. Oh, that it has a clone. That has a clone. Okay. Okay. So see here once again. So this machine has a clone, right? So if I clone once again, find the number of files that is having one. So we have got two hard disks. This is the clone and this is the original one, right? So if I clone it once again, I should get one more hard disk. So manage, clone, click on next, click on next, click on next, and okay, so this is clone 2, finish. It's close. So this clone 2 is created in clone 2 is created in cos. Okay, so let's come over here. See the number, this file has increased. So this is exactly the delta file, right? So see the size 2.56. 1.11 so this is exactly this 3.64 GB. That means this is the original file, and once I clone it exactly, it is creating an image of it. It's creating a mirror of it that feels like it is the original machine, but it is not the original machine. It's only the changes made to that machine.
So like whatever I will be writing to this second clone, it will be written to this file.
This file, whatever I will be writing to the first clone will be written to this file. Whatever I will be writing to the base image will be written to this file. And if I lose this disk over there, everything will be lost.
But in this case, I see a problem.
Yes, please.
Suppose I create a clone today of my image. So it will create this cos A file, right? So whatever this situation of my machine is today for my original base machine, it will be saved in this file, right?
Correct.
And then my clone, whatever changes I will be writing to that clone will be written to this clone file.
Right.
So after 20 days from today, whatever changes I will be writing to my original machine, so will they be keep on adding to this base file?
No. Each and every image is having its own identity. right? That means if you
So the
make some
original
changes,
machine will also have another file associated with it, the
yes, yes,
delta
yes,
file.
yes, yes, yes. That means if I make some, if I write ABCD to my base image,
Okay.
it will be written in this hard disk. There will be, if I power on this clone over there, I will not find ABCD. If I write EFGH over here, I will not find EFGH over here. I will find EFGH over here. If I write PQRS over here, I will be finding PQRS over here. Not here, not here.
But then I should be having one delta file for my master, one delta file for each clone. So 3 delta files should be there, no?
That you can, that is not the way they exactly create it, right? And if you want that way, that can be done using this method. Clone, click on this. Now there are separate snapshots exactly that has been created. That means they have exactly created a snapshot of every instance when you cloned the thing. So if you click on this one, it is going to take the clone from the first snapshot, sorry, take the snapshot and again clone it from the first clone that you created.
Okay.
Anything else to ask?
Yeah. No, it's okay. Yeah.
Cloning is nothing but a methodology to save space, right?
Mhm.
When we don't want exactly to build the whole machine right from the beginning. I just have the machine, I want to give it to somebody, all right? It should feel like that he's working on a separate machine, but I don't want to give him a separate machine, so clone it. That is it, finish, nothing else. You will be saving space. There is one more method where you want to, okay, let's say there are certain people, there is a loophole here. There is a loophole here. I agree with your statement that if I lose this one, if I just delete this one, let's say delete, okay, so delete it. Okay, so if I power on this machine, now what will happen? Will I be able to power it on? So I think I'm using the wrong machine. So if I lose that base image over there, I am going to lose that machine. I'm not going to exactly this machine will not be operatable. The clones will not be operatable in that case, right? That I'll show you in your type 1 hypervisor. So
Okay.
there is a method to protect my whole infrastructure that is called full clone. Let's say some people say that, okay, I need a full machine. So click on clone, click on next, click on next, and create a full clone. Click on next, and this is the method where you exactly get the full machine. Hang on for a second. Create a full clone, click on next, and just finish it off. This takes a bit of more time, you can say. So see here, file not found. It's telling you that the original machine is not found. That is why you cannot do it.
Okay.
The point is that there are again two types of clones: linked clone and full clone. Full clone means what? Exactly copy. That which is tightly copy paste. It's going to have consume the same amount of space. Linked clone means it's going to consume less amount of space. But there is a loophole. Full clone means the original image, it's gone, still the machine is there. The clones are there. Linked clone, if the base image is gone, the clones are not there.
Okay. Yeah.
Right. Okay. So let's do last thing over here. Last thing of the day. So what is a snapshot? So if I take snapshot, okay. So okay, let me show you this way. So I am going to create what is a snapshot? Snap exactly means picture, right? So it's going to take a picture of a state. So if I take a snapshot before deleting disk, okay, take snapshot. So I took a snapshot and I named it before deleting disk. So if I go to power, I power it off. And if I click on this disk and I remove it, if I click on this disk, if I remove it, okay, this is some unnecessary misconfiguration that I did, right? Take it that way, right? That somebody mishappenly did this thing or desperately did this thing, just but this happened. This is now faulty. This is a faulty machine. This is not going to power on, and this is not that. Okay, so this machine is not powering on. Fine. Now the point is, if I go to settings, one more thing, snapshots can be taken when the machine is on, when the machine is off. The configurations can be wrong either at this page or when the machine is on internally. That means I internally deleted some registry setting, I internally deleted some file, but still the snapshots work the same way. So if I want to revert the machine to the original state, so I'll go to this one and click on this before deleting this and click on yes and see what happens. The machine comes back to the original state. We are not doing very big science and very big new thing over there. Don't we do Control Z in Word when we do something wrong, going back to a state? It's like a time travel, going back to certain state over there, right? So since these are files, all the treatment of files can be done. So we are doing this as if we are working on a Word document. We just moved on to certain state where exactly the machine was working properly if we have taken a snapshot. So let's say I want to go to some another state. So there are several snapshots that I have taken earlier. So before clustering, so if I click on this and click on go to and click on yes, I'll be moving to some other state. So snapshots is nothing but a methodology that has been adapted, which lets us move to a different state. It's exactly lets us time travel on a machine. So see, the machine is on. We took a snapshot when the machine was on. So these are certain beautiful and you can say eye-catching things that can be done in your virtualized environment, which cannot be done in a physical environment. Physical environment, we cannot do this thing, right? We cannot move on states of machine. In Solaris, we can do that. Solaris has got something called snapshot. The snapshot methodology is inbuilt into that. But again, we have adopted that snapshotting methodology from Sun Solaris or Oracle Solaris, whatever you call it in this virtualization. And we have brought it to you so that you can travel on time. So where we will use that case scenario, let us say that we have got 5 steps in which a server is configured. Let's say mail server. A mail server has to be configured in 5 different steps. And we are pretty sure in 3rd step, we are going to mess up. So what we'll do, in first we'll complete first step, we'll take a snapshot. We'll complete second step, we'll take a snapshot. We'll complete 3rd step, we'll again take a snapshot. If we are not able to complete the 3rd step, we'll again revert to 2nd step. We'll start from second step. We don't have to start from 0 there. Any question?
No.
Sure.
So the files which will be created in snapshots and the one we did for cloning, so they are kind of similar things, which are
similar things. Cloning itself creates a snapshot, and once we create a snapshot using this right click and manage, we manually do that. So snapshot.
Okay. Yeah. And I was reading somewhere that snapshots is not a good way of taking the backups. It was written somewhere that snapshot, if you want to take a long-term backup.
I never said that snapshot is a method of taking backup. It's exactly to stay in a time. It's a picture of a time, right? It's exactly used when we exactly move towards configurations. That means we exactly have to do certain phases of configuration. In that case, we'll take a snapshot. Snapshot is not a methodology for backup. It is not even you can say the other side of the coin to backup. That means it's not an alternative to backup. It's nothing. It has nothing to do with backup. There is a separate technology called VMware Data Recovery (VDR) that is used to take backups of virtual machines.
But why is it said so? I could not understand. Like we miss some files when we take snapshots, or why is it said so that it's not a good way?
Snapshot. Okay. If you have used this, have you used System Restore in Windows?
No.
No. Right. So there is a methodology in Windows. This snapshot is nothing new, right? This is exactly adopted from the operating system or your operating system features over there. So if you go to system protection, there is something called system restore. You can undo system changes by reverting your computer to the previous restore point. So if I click on system restore, I'll find certain restore points over there, right? This restore points exactly takes me to a certain, so this you can see over there that this restore point was created on 17/1/2018. So is it 17/1/2018 today? So it's 24, right?
24.
So it was so I removed open office this version and it was an uninstall. So this is a critical, that means these are the snapshots exactly for my operating system, right? So I can move towards, that means I just didn't like this thing what I did, right? So I can click on this and I can click on next and I'll be moved to that situation. The point is that in that case my files will be lost, right? So do you think that we do backup to lose a file? We don't do backup to lose a file. So snapshot
No,
exactly loses the files.
if on the day on which you created this snapshot, you will have all the files for that day, right?
Mm-hmm.
Only after the snapshot was created, you will lose the files, whatever was there after
Right.
you took the snapshot.
There is
So
also
if
one
I
error
take a
called.
backup, if
There
I
is
take a
also.
backup today,
Uh,
and after 10 days something happens to my system and I want to restore my system with that backup, it will not be the same thing.
Theoretically, it feels like it will work, right? But what will happen is that there are certain. See, theoretically it will work, and if pray to God, if God exactly has given you some blessings, right, it will work the way you are thinking. But there is something called snapshot consolidation, right? So if the snapshot is not consolidated properly, there these machines are not even going to come up, even if you have taken the snapshots properly, right? So
Okay.
there the snapshots are exactly prone to errors. That is why we don't use it as a backup.
Okay. So it's not a very robust thing. Snapshots
No,
are
it's
not
not
very
a
robust.
robust thing. That means VMware does not recommend it.
Okay.
Though
Okay.
you we feel like that, okay, fine, it should work. It will work. It works with okay even. But again, if God has blessed you, then only. Otherwise, you will face problem.
Okay. So then it means that snapshots are just for considering maybe for a few days or like
Considering for a few days. Otherwise, if you are going for a stepwise configuration method, that is it.
okay, okay. So nothing for a long term, only for short term
Nothing
changes.
for a long term. Nothing.
Okay,
Even
okay.
backup strategy is even in fact the same way we used to do 10 years earlier. The methodology still is the same. Backup has not changed much over there in since last uh, 10 or 20 years. The media we used to take backup has changed, but the methodology still is the same.
Okay. Yeah.
Right. Your network, you are a network guy, right? So you might be knowing that we have even virtualized the network. We don't use routers even in the physical form that we used 10 years earlier. So we have virtualized our routers, we have virtualized the switching methodology, we have virtualized the VLANs. So you can very well think that almost everything is going to be virtualized in next few years over there. But still, if you consider backup, the methodology still is the same old traditional method.
Okay, okay. Yeah.
Right. So I hope that it has been informative for you, and thank you for being with me. Right.
You're welcome. Yeah, thanks for this session. And a few things I wanted to know about the course.
Please go ahead.
One is the networking part of the vSphere, like creating all these distributed switches and how the interconnection of the networks work. So we will be covering this in detail, or we will be
We'll be covering
doing
that
it
in.
on
We'll be covering that in.
in
We'll cover it.
detail.
Distributed virtual switches. It looks complicated, but once you find the key to tune that DV switches, you will feel that it was so easy. It is like a normal switch only.
Yeah.
Right? The point is
Okay,
that
okay.
you have to catch the key and rotate it properly to open the lock. That is it.
Mhm.
Nothing else.
Okay. Okay, and what will be our duration of the course? So we will be doing like 1 hour session every day or 2 hours, or how will it be?
I'll expect it to be be between 1.5 to 2 hours.
1.5 to 2 hours.
Right.
So it will be like 50 hours in total?
40 hours. 40 hours.
40 hours. 40 hours. And every day, like 7 days a week or 5
I'll
days?
preferably take it at least 6 days a week. If not 7,
Okay.
then 6 days a week.
Okay.
Right.
Okay. 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 So I can say roughly it will be like
That will end up in
20,
February.
25 days. Will
February
be
has
roughly.
28 days. That is what.
Oh, end of February, you mean to say.
End of February
If
will
we
be
start tomorrow, then that
if we start
what you
tomorrow.
mean, right? Yeah.
Right.
Okay. Because for this, Srinivasan is also there on call, right?
I hope so. Srinivas, are you there?
Yes, Vinay.
Yeah,
Okay.
Srinivas.
So Srinivas, yeah, as I discussed